All right, example problem number 3. We are pushing a book against a wall. They give us the coefficients of static and kinetic friction. They tell us the book is initially at rest. What is its speed as it has traveled 4 meters up the wall? 0.4 meters up the wall. Important piece of information here that puts into context everything is that it's sliding up the wall. So if it's sliding up the wall, we have to think about this in terms of friction. If it's moving up, right, friction should be going down. Also implied in this, and we'll get to the math later, but it's moving, so it's going to be kinetic friction. So our force diagram should account for the force exerted on it, which we'll label as F. The force of the earth going down, mg. Also friction pointing down. And then the normal force here of the wall. I'm going to label my angles, and then I'm going to draw in an axis. So we have our positive y-axis, we have our positive x-axis, and then I'm going to write out Newton's second law in variable form. So horizontally, we are going to get the normal force of the wall on the book minus F times sine of 60 degrees over m is equal to 0. So that's in the x direction. In the y direction, we are going to get, and a quick mistake there, that should have been cosine of 60. My bad. We will get F sine of 60 minus mg, the force of the earth, minus friction, and that would be kinetic friction in this case, over m is equal to the acceleration. So here, if we look at this, solve for the normal force of the wall on the block, it will equal F times cosine of 60. When you substitute 96 in, you end up getting 48 newtons. So to determine the acceleration, okay, let's say for a moment we were unsure of what friction to use. So the friction part of this, the normal force would be 48 newtons. Okay, mg is going to be minus 50 newtons. That's 10 times 9.8, and F times sine of 60. All right, that is ultimately going to be 83.1 newtons. So even if we put the coefficient of static friction in, which is 0.5, which would give this whole term answer 24, and subtracted 50 and 24 from 83.1, we would still have a net force going up. So you don't have to, if you're overcoming the static friction, it's automatically going to go to kinetic friction. So you don't need to worry about, if you know it's moving, you don't need to worry about figuring out if it overcomes the force of static friction. So ultimately, our acceleration is going to be 3.75 meters per second squared. Now to figure out the speed in which it's moving at, we're going to have to use our motion equations. V squared is equal to V initial plus 2a times delta x, which is 0.4 meters in this case. After substituting everything in and taking the square root, we're going to get the square root of 2 times 3.75 times